Excellent. So I started a little early. How's everyone doing?
Good. How are you?
Very good. Very good. Good, guys. Get some things going here. All right, guys, I know we are waiting on a few more people. So in the meantime, we could start. Do you guys have any questions with everything what we've been doing? Now's a good time to go ahead. Let me share my screen. Okay. All right. So I think we should do a quick review and then get going. So I think I feel pretty good about this week, guys. I think things are finally kind of going the way I wanted. So now we all, how do you say, we all kind of understand how this works. And I see assignments, you guys are doing your assignments. So that's all pretty awesome. So let's start from here, right? So everyone should be here right now, right? In the virtual classroom, sorry, class notes. Okay. So everyone is here. Let me put this link one more time. I'm curious, anybody here who is just joining today for the first time?
Well, I mean, I tried last week. I mean, I was doing this late because I only saw this last week.
Gotcha.
I tried last week, but I didn't know how. So now I'm in. Thanks.
Sure, yeah. So, and the way it's sort of structured is, let me bring up the weekly, right? I had people writing to me and said, things like, they know Python pretty well, or they know, they've done some data science. Can they join in the middle? By all means, yes, right? So, so because, we've been sort of, kind of what we've been going through is kind of what I call prereqs for machine learning. So, basic Python, because I know a lot of us we kind of come from a Java, C background, so I want to get a Python thing going real quick. So we are done with that, right? We are done with the sort of the prereqs. Going forward, we are going to start in the core machine learning in the upcoming week, right? Yeah, so yeah, absolutely, right? So you can join anytime. So one thing I recommend is kind of look at the curriculum, kind of make sure, look at the reading material, and then make sure you are comfortable, right? And then maybe if you like, you can sort of try a few exercises just to kind of brush up on your skills. That's it, right? So because this is a long running series, so we want people to join anytime. But at the same time, we want to make sure you are following along, right? You're not left behind. So that's why, everything is published here, so you can follow along at your own pace. Excellent.
I'm sorry if you have mentioned that already. Is this the second week?
No, actually, we actually at, actually, this is week 4. We're just wrapping up week 4, right? Okay. Yeah, so, and the next week is going to be a break. You can, give you a chance to kind of catch up. And then the week after that, we are going to start the next section, right? So they're going to make sense, right? So we just got, we're going to wrap up week 4 today, and then next week is, it's a light week, and then we'll kind of begin after that. Yeah. Okay. Any other questions, guys? Logistics wise, anything, right? This is your chance to kind of, speak up and let me know your feedback. Yeah.
Oh, you sure got some nice resources. Personally, I started this practical statistics for data scientists. So that was,
Oh, the book.
Yeah.
Yeah, actually, yeah, that's a great book. Where did I mention this? I think stats, right? Somewhere here.
Yeah.
Yeah. Yeah. So as you guys know, right? I mean, so again, there's a little bit of a confusion of what we are following. So again, basically, this is a doc, right? I'm kind of maintaining this doc as a master document. So if you look at the GitHub, so the one I'm developing this, so think of it like a little open source book, right? Kind of, right? That's it. So just like, any textbook, we're not going to do this like everything in one day. So they're going to broken up into pieces, right? So, and if you're wondering like where, how we are following, that is our weekly curriculum assignment, right? So if you look at this link, basically, this is how we are breaking them up. Because, we are kind of doing this on a weekly basis, with limited time on everybody. So that's why it's kind of broken down on a weekly basis. Anyway, so that's where things are. So if you look at the stats, usually when I give you guys the links, I like to make sure they are free and or open source. But there are sometimes I'm going to give you guys some good books. And this is a really good book I highly recommend, Practical Stats for Data Scientists. Right, so definitely worth getting, or either. So the way I sort of read this now is I have a subscription for O'Reilly. So we click on the O'Reilly link, right? It's going to take you to the O'Reilly page. So what O'Reilly has, they have like a monthly subscription now. So what you can do is you sign up and you can read all the books online. And they have like a nice apps for smartphones and tablets as well. So I'm a big fan of this. I don't know how much it is. I think like a $50 a month or $50 a year or something like that. Anyway, you can find out what the rate is. Not only they have O'Reilly books, they also have books from a lot of other publishers as well, and they have videos and everything. Anyway, so I will give you guys links again. These are not mandatory, but if you're thinking of if you want to get a subscription, I will highly recommend the O'Reilly subscription, right? You can read a lot of books. Personally, I like to read books than watch videos because books I can quickly skim through, right? And I know I can sort of say, oh, I know that I can skip. Videos, I can have to watch the whole thing. So from an effective perspective, I much prefer books. And I know, don't get me wrong, I like some videos too, because especially when the videos are has a lot of animations and things, then videos are really good. But if it's just, bunch of slides, right, then I'll rather, skip through a book. Anyway, long story short, if you can, get a subscription. And I know they used to offer the subscription for free if you had a library card in US. So you want to sort of go to your library. If you're a member of a library, go to your library page and kind of look for directions on how to get access to this page, to the service. It used to be called Safari Books, right? Now they are rebranded to O'Reilly Learning or something. Anyway, worth checking out, right? So again, like I said, optional, but highly recommended. All right, guys. So any other questions of this week? So I know one feedback I got was the reading list was a little too long for stats. I get that. Thing is, there are some basic concepts in stats we sort of need to understand, right? Again, I mean, again, this is, if you look at this is kind of like an intro to stats kind of a thing, right? We haven't gone into any deeper or advanced topics at all. But this is some basic things we just need to kind of keep in mind. So I gave you guys a bunch of links. Again, right? Do the best you can, right? I kind of wanted this to be complete. That's it. So if you're gonna, if you just end up like doing like one, if you're limited in time, I would just recommend like just read like one article per section. You know what I mean? So this way you can spread out a little bit, and if you have time, you can always go back and read more. That's what I would do, right? So I wouldn't do like spend a lot of time like reading like everything on the first two and then skip the rest. I would not recommend that. Do like kind of do everything, but just on a kind of a on a lighter level. Does that make sense, guys? Yeah. But the exercises, you guys did pretty well. I sort of, I skimmed through a few notebook submissions. You guys did pretty well, and I'm going to demo them right now. Very good. So, anything else? Is everything kind of going there okay? Any other feedback?
Hey, Suji, this is Kanchan.
Please go ahead. Yeah.
Hey, so this is regarding an assignment. I don't know if you want me to ask you right now or after the
yeah, actually, yeah, we are going to go through the assignments now, so
okay.
maybe that's a good time. I see a question, can we submit late? Please, yeah, absolutely, yes, you can. So here's the thing. Again, this is something I'm you guys, I'm trying out, and we'll see how this goes. Submissions, we are doing it through Google Classroom, right? Where's the Google Classroom link? There we go, right? So again, remember, Google Classroom is written for a sort of a traditional classroom where your students and you can submit and I grade, but we are not doing that model, right? So pretty much the only reason I'm asking you guys to submit is basically we are sharing with each other, right? So we are not using a lot of other features of Google Classroom. So one of the cool things it allows me to do, excuse me, right? So if you can see my screen, here's a classroom. So here's here's our class, right? And they actually create like a Google Drive. So all your submissions basically go into Google Drive, right? So, right, so I can sort of see everybody, and also it makes it easy to share the whole entire drive. So I'm kind of using this as a glorified file upload right now, right? I'm not using any other features of Google Classroom, but let's stick with it because we started using it. You guys kind of figured it out, so I'll keep at it. Yeah. So is that gonna make sense? Because and the way I'm making this public is if you look at our curriculum again from out here, right? Come to the curriculum assignments. Each week you will see a solutions, right? So I basically open up solutions on Fridays, I think, right? So this way you can take a look at this. So for example, stats 1, right? So you can click on this, right? You should have access to this, the folder, right? And you see the submissions. And I would like to see more submissions, please. So even if you're running late, here's the thing, right? You don't, even if you're not 100% done, please submit, because that'll kind of keep you motivated and also keep you on track. Because I'm the prime example of this. I procrastinate all the time. But if I say, hey, I need to submit this Friday, right? And then it's at least, whatever, if I'm like 60% or even 50%, I just submit it because, this way it's kind of, right, I'm done, right? Kind of forces me to be disciplined. So please don't fall behind. Don't let you don't have to do all the assignments. Kind of, do the best you can. Like, for example, let's say you only have to do like, first 2 exercises, so be it, right? But please submit, right? And then you can always submit later, right? So in a Google Classroom, what you can do is, I think you can resubmit, right? If you go to the classroom, they will, they will show you how to resubmit. So, yeah. So the way I'm sort of, right, and again, I like to make this public because this way you can all learn from each other, which is what I'm going to do this week, right? Because this week I don't have my own solutions. I'm gonna showcase some of the solutions you guys submitted already. Okay. Anyway, so that's the idea, right? So you see all the submissions folder, and also, so a little bit of a motivation here for you guys is like, So you know everything you're going to submit is going to be public, right? Which is for the, public for the class. So it kind of forces you to be, not to be too sloppy, right? Kind of a little peer pressure. So I think that's a good thing, right? All right. So this week we had 2 modules, stats and data cleansing, right? So we're kind of building up towards this. So it starts for a lot of reading, but the exercises are pretty straightforward. I want to just have you guys a little idea of how to do some basic stats. So solutions, right? So you see all the submissions folder, and I'm going to go through a couple of submissions submitted by one is Kiran and another one is Vaseline. So thank you guys. I sort of randomly checked, and these are really good. Again, I didn't go through all of them. It's just I just randomly picked, and every week I'll try to sort of randomly feature a different person, right? So don't worry, if your code is not complete or anything, I'm not going to embarrass you. It's just, but I do like to highlight some of the good work you guys have been doing, right? So same thing, right? So this week, Kiran and Vaseline. So thank you guys for submitting a solution. Good. So let me kind of quickly review these, and then as we go through, you guys can ask any questions if you have. So let's look at stats real quick. So what are the assignments for stats, right? So stats basically is, right? So a lot of reading, but basically, we just want to get you guys some basic stats. So I started with some real world data, NBA player stats, right? And then I said, okay, look at the salary, and basically, just make some sense, right? What's the average salary, which is mean, right? What's the mid level? So mid level is like the midpoint, right? Median, right? Midpoint. And is there a large variance? I'm sure you found there's a large variance. I do like a little graph, right? Right. So basically, the idea is basically understand the salary of NBA players. Right. So I just give it. So what is the salary column? If you look at the salary column, let me show you guys this. Let me actually bring up the here's the file. Let me bring up the file here. Download this. You can open an Excel spreadsheet if you like. All right. So let me close this. All right. So here's right. Here's the stats. Pretty straightforward, right? You can sort of see player name, team, what's the jersey number, what position they play, age, height. Interesting. Why is it saying height? That's a year.
Yeah, so this is the issue I was talking to you about. So when we download, Excel converts it into a date. So I just wanted to see how you handle it.
Right. So I usually put like oops. It's just a regular. Okay, actually, you know what? Sorry, this is wrong because it shouldn't be that. It should be just a text because where was that? I think I messed it up. Sorry, guys. 1 second. Because it's doing a how do you say feet and height kind of a thing, right? So I'll just make it as text for now, just to. Why it keeps okay. All right, guys. So this is some Excel magic. Anybody figure out what type this should be? I'm trying to figure out. Okay, what?
It is a text, to be honest.
Just text, yeah. But even when I do text, it's kind of doing this weird thing.
Yeah, that's the problem of the import thing. I don't know if you try to import it again.
Right. Yeah.
I converted it to
clarified.
Yeah, actually, you know what? Let me just look at the raw data. That's probably easier. Okay, anyway, so that's kind of weird. Yeah, so basically, if you look at the data, can I make it raw, display raw, something? Yeah, I think Excel's trying to be too smart. And
no, I think, Suji, this happens in the import state.
Oh, I see. Okay, yeah, I think so. Yeah, you're right. Yeah, yeah. All right, I'm just going to try one more time, guys, and then I'm going to leave it alone. Let's see if that works. All right, never mind this. Okay, I'm just going to show you the real data because the data here is kind of in a format like this, right? It'll say 6 feet, whatever, like 4 inches, something like this, right? Like feet and inches. So it's kind of represented like this, more like, if they say 6-4, and what Excel is doing is kind of thinking this is like a date, all right? So you will see a lot. If I make it as a date, you will see there are a lot of people, in June, because 6 feet, right? 6 feet is the most common, right? So it's a 6 feet, 6 feet. That's like 1 feet. You know what I mean? Anyway, so you get the idea, right? So yeah, it's a kind of don't worry. This is the Excel thing, nothing wrong with the data. All right, weight, college, and salary, right? Okay, so basically, what I want you guys to do is analyze the salary column. And as you can see, right, there's a lot of, you'll see, right, just like, any other sports, there's going to be a big variation in the salary. All right, so let me look at one of the notebooks. Start with the, say, Kieran. So start with that. So again, notebook, when you click on this, remember this is Google Docs, right? You can download it if you like, but usually what I like to do is like just straight away open with the Google Call app. It's very handy. It'll open for me, right? And another thing you have to remember you're looking at a shared notebook, right? So you cannot make any changes. So what I recommend you guys should do is like you should save a copy, right, in my own drive. So this way, then it makes a copy in your own Google environment, which then you can modify, right? Right. So I'll just close this guy, right? So this is my copy now. All right. So let's read the data. There was a reader. Read CSV. All right. So yeah. So again, now I'll just want to show you guys some of the data. Right. Oh, sorry. The URL. Give me 1 second. So this is the cool thing about Pandas. You can just read the URL directly. Oh, there we go, right? So this is what I want to show you guys. So again, look at the data, right? So height is basically like this, right? Anyway, so in this case, we are focusing on salary for now, and you'll see like some of the salaries are missing. Like you see, not a numbers kind of coming up, and this is again kind of ties into the next lab, but you'll see, right? So, so you can sort of see here, right? Some of the salary data, and you can start doing some graph. This is a pretty cool graph. We can sort of see this. So what Kieran has done is he did like a little box plot, right? So how salaries vary, and this is a kind of a. Let's see if we can make it a little bigger. Right. So right. Actually, maybe I can. Let me do this. And anyway, you can sort of, you can sort of look at the matplot option. You can make the graph bigger. But I wanted to show you guys some of the. So this is a pretty cool plot. I really like this one because here, if you look at this, you sort of see some of the teams have very good, very big variation. Like look at the Cavaliers, right? Obviously, right? So it has like a huge variation. Why? Because there are some star players that are getting paid so much money, the more than everybody else, right? So you can sort of see the line stretching all the way to the. Let's go to the next one. Miami Heat, obviously, right? Miami Heat. Has the star. Anyway, so you guys get the idea, right? LA Lakers probably somewhere here, right? Warriors, right? Warriors are kind of right? Reasonably okay, not as extreme as these guys. Spurs. So this is pretty cool, right? So again, this is exactly why we did the graph section earlier. So now, in one snapshot, you kind of see, get a pretty good idea of salaries, right? Does this make sense, guys? This graph box plot, right? So what the box plot has done is basically, right? Again, you can look at the code, you access the notebook, right? So so it's a basic box plot, right? Per team, right? And the salary, right? Salary on this axis, right? So that it's a side of is like millions, right? Basically a million, whatever, right? Like 10 to the power 6, like right? A million, and then goes to double-digit millions. Any question on this one, guys? So again, you can look at this notebook, right? The links are here, right? So I'm looking at the notebook by Kieran right now. Yeah, really good work, Kieran. So again, I really like this one, right? So and then also, again, there are. This is not the only way. This is just one way of doing this, and I'm sure you guys came up with your own way of kind of visualizing. I'm always a big fan of this. Kind of visualize the data a little bit, just so you understand this, right? And then also, I'm asking. Things like use some basic stats, right? Again, you can look at the right NP, right? You'll see averages. Those are pretty straightforward, right? Also, this is pretty cool, right? I like this is kind of like a by position, like point guard, right? Safety, right? So you can sort of see here the salary version on this one too. I thought that is pretty cool. So again, if you look at the data, right? In the data, you actually have, let me go up here, the position they play, right? So we want to do like a little analysis of how much salary, by position, right? That's pretty cool too, right? So you can sort of see here. So pretty good job. And also, right? So he used Seaborn, SNS, right? Seaborn, and like I said, Seaborn gives you like pretty nice color graphs. So I'm encouraging more and more people to kind of use Seaborn, even though Matplot is by far, the most used. I'm kind of pushing people towards Seaborn because you're kind of using Matplot engine anyway, but you get like a nicer graphs to look at, right? I'm a visual person, so I like to look at nicer graphs. So.
That's cool. I wish for I think I got two questions. One is, are there any metrics for Seaborn, because I missed the last session?
Sorry, you broke up a little bit. Ask me one more time. One more time.
Are there any magics for Seaborn, like inline or something, or does it just come in the Python notebook?
Yeah, Seaborn. You mean Seaborn package? Yeah, Seaborn package is pretty much included with Anaconda, right? So he's importing SNS Seaborn. We go all the way to the top, right? Import Seaborn as SNS, right? So yeah, so Seaborn is pretty much a it's bundled right now. Yeah, so if you have Anaconda, you would have it. Yeah.
Okay, cool.
So pretty cool. Anyway, so again, another thing you would ask is, all right, so question. Let me see if I can, let me see if I can make this a little larger for you guys. Okay, so hopefully that's better. Actually, let me do this. So, all right. Yeah. So another way I'm going to recommend to you guys, right now that you guys have access to another solution, if you just look at other people's code, that's fine. But I mean, to me, what I usually like to do, right? So let's say I have Kiran's notebook I want to learn from, right? I would actually create my own notebook, right? I'll start from an empty notebook, and I'll say, okay, so I'll make myself some notes. So okay, I'll say read data, right? So that's basically pandas dot whatever, right? Read CSV, right? Something, right? So that's my data. And I'll say, okay, how's the data look like? Did I get that right? Okay, that's good. Then what I recommend is like you just create individual cells. I say, okay, then I just say, okay, you say salary, mean, median, whatever, right? And then sort of do like NPy dot. By the way, right, again, NumPy has all these things, built in, so you don't have to do any of this. So for example, right, you can sort of see here, right, NumPy mean, right, NumPy median, all this is just one-liners, okay? So very easy to do. And then I'll say, okay, let me do the median. But let's say I'm stuck on, something, right? I'll say, okay, I don't know how to calculate this. Okay, then I go look at the code. I say, okay, how did this person do it? Oh, okay, so I see like a little thing here that made them, right? So that is how personally I learn, because if you simply just say, runtime, run all, if you ran the notebook, on your own, there's not a lot of learning, right? At least personally, I the way I learn is like I actually type the code. I don't even copy paste, right? I actually type the code. Then, to me, like, I don't know. That's kind of how my brain is wired, right? And I know a lot of people are like that. So that's what I recommend. So don't just look at the code and say, oh yeah, I see how it's done, and kind of move on, because then, you're not really absorbing much. Please try to do it. And when you get stuck and say, okay, hey, okay, how did he, extract some, right, something, then go look at the code. Does that make sense, guys? So that's what I recommend. So now you have a lot of code to look at, right? You can look at how other people have done this and compare your solution with them. So the shared learning, okay? All right, guys, so that's that. Let me see what else I want to highlight here. So okay, graphs are really good, right? And also, kind of like this is basically, right? Again, sort of, right? Average sort of, this is like a frequency distribution graph, right? Again, remember we were doing a scatter plot, not scatter plot, a frequency plot, right? So look at the graph here. What else I want to highlight here also? Oh, next thing I asked you guys is correlation, okay? So I said, okay, in the NBA data, you have height and weight. Do you see any correlation between them? Right, as in like, are they, when one goes up, does the other one goes up too? Remember, this is what we did yesterday, right? I'm not yesterday, last week. So how do we kind of, even find that out? So first thing you got to do a couple of things. First of all, as you can see, the height is kind of, in a messed up format, right? So first thing you got to do is we have to convert the height into actual number. Because right now, this is like a feet dash inches format. So use the formula, right? You sort of see, you sort of see here, people are done, so basically you got to sort of do some little string parsing, right? And where was this? Sorry. I remember seeing this. Right. All right. There you go, right? So, sort of computing the height centimeter, because basically what you're doing kind of doing like a little formula, right? To basically split the data into two, right? 2 columns. So yeah, there we go. That's what I was looking for, split. Oops. Right. See, we're kind of splitting using the dash, because dash is the separator, and the first part is feet, second part is inches, and you sort of doing like a little, little math, right, to calculate the height in centimeters, and basically you make it as a column, right? So basically you have a new column that has height in centimeters. All right. Once you have this, what you can do is, okay, now you can compare height and weight, because those are just numbers, and you can sort of do the correlation, right, and then see how they look. And when you look at this correlation, you will sort of see here, right here, right? This is a correlation matrix. So we know how to read correlation matrix now, right? So right? It's a 2 by 2 matrix, height and weight. So obviously the diagonals are going to be 1. We know that, right? Because that's the variable with itself. Sure. And look at the correlation. So height and weight, they are about 82%. So you would say, they are pretty, pretty well correlated, right? People that are taller tend to weight more. Does that make sense, guys? Again, I mean, this is exactly why we did like the basics, in the previous weeks, because now, if I ask you guys a question like, hey, do you guys think these are correlated? You can quickly say, sure, yeah, I can do like a quick correlation matrix and then say this, right? And also, and this is a neat way of doing this. This is a correlation matrix as like a plot, right? So basically what you want to look at is like, you want to sort of see, right? The way it's color coded is like, if it's like, right? If it's, right, look at the color coding, right? So 1 is like this, this dark, no, the light color, right? And use the diagonals are 1, pretty much, right? And then you sort of look at the scale and then sort of say, okay, so like, maybe like black here, right? Is like, around 80, whatever, 82%, and you sort of see the color coding. So it's like, it'll give you like a different shades. Let me see if there's a different one here. I think I saw one. Oh, there we go, right? So here's another correlation matrix. So you sort of see the, see the diagonals are the light color because they are like 1, right? You can look at the scale, 1. And then kind of, at a different color scale, you sort of see, right? Okay, this is like, maybe like, red is like, somewhere like around 50%, right? And light orange, maybe like 80%. So it's kind of like a nice visual way of, looking at a correlation matrix using colors. So pretty neat, right? So, again, these are like little tricks you can do. Sure, I mean, you can look at the numbers, right? I mean, numbers are fine too. So here's my correlation matrix using numbers, right? You can sort of read the numbers and say, okay, yeah, 1, 1, 1, and right, you can sort of see 68%, all that. But also you can sort of look at it using a nice visual representation. That's pretty cool. Yeah. All right, guys. So height and weight. So you can see the correlation matrix. You can say, yeah, they are pretty well correlated. All right. All right, guys. Any question on this one so far? All right. Okay. So if you look at this, in this space, there's a bit of a reading data, kind of doing some basic data manipulation, and this is usually what you will encounter. Like when you get data, right? It's kind of like you might get data in this format, right? Basically, it's not exactly the numbers, but the data is there. You just need to kind of massage it to a different format. All right, guys. And final question is another correlation. I said, okay, load house price data and do a correlation matrix and figure out which attributes track sale price better. All right. So let me show the solution real quick. Sorry, that's the last one. So reading the house sales data, right? And if you look at the correlation matrix, very simple. You just simply say, right, correlation right here. Right. So it's going to be correlation matrix. Okay. So the way Pandas does it, it's kind of splitting the data into two, right? Because it's kind of, it has a way, it's kind of, running out of vertical or horizontal space, right? There's a setting you can do, so it all kind of comes into the, into the same, right? into the same array. Let me see if this can be done, right? Or you can print out the data frame itself. So here's the difference, right? If you just want to print out to the data frame, right? We just say, right? We just print the data frame just as a last line instead of doing print, because print will print a text form. If we just print the data as itself, right? It'll do like a nice pandas data frame. So that's another trick you can use, and it'll kind of do like a nice formatting. It'll give you like scroll bars and everything. It'll print everything in one thing. Anyhow, so let's look at this correlation matrix real quick, right? So it's going to split it two, right? Remember that, right? So sale price, these are some of the attributes, and these are the other attributes. So can you just look through here and tell me which one of these attributes is highly correlated to the sale price? Let me see if I can pick this up. Give me one moment. I'll just do another one just to kind of quickly. So this works. All right, that did work. All right. So there we go, right? So remember, so this is actually data frame, right? So this is actually data frame. Again, I'm using a really bad naming convention, but you guys get the idea, right? So if you just print the matrix by itself, so when you say correlation, it's going to give you a matrix. That's again a data frame. And if you actually just say print the data frame by itself, it's going to give you a nice format, right? So I sort of find this nicer than just print, because print will actually convert everything to text. But here you sort of see, right, when you move your mouse, it kind of highlights the rows and everything. It's pretty nice. All right, guys. So we are looking at sale price. Look horizontally, right? Again, look at the matrix, like, the diagonals are 1, right, as they should be. So let's look at sale price. Looking at the matrix across, let's see which one's going to give us, track sale, give us a better indicator of sale price, right? Meaning, so we are looking for correlation. Remember, correlation between -1 and +1, right? So correlation is between, right, -1 and +1. So anything towards +1, highly correlated. Anything towards -1 is highly negatively correlated, right? If it's like around 0, basically no correlation. Yeah. So what do you guys see? So I'm looking for something close to +1. So bedrooms only about 31%, right? So okay, fine. Bathrooms, even I think compared to bedrooms, bathrooms tend to track better than bedrooms, right? So they're like 51% influence sale price, right? Square foot living, let's look at this, right? That's 68%. So that seems to be the biggest correlation, right? So the size of the house, square foot living, 68%. You sort of see that, right? So in one glance, you can sort of see how the variables are correlated. That's pretty good, right? So, so what else? So year built, yeah, I mean, not that doesn't seem to be that big of a impact, and there's a reason for that, and we will see. Zip code also, by the way. So this is interesting. So it's treating zip code as numbers, but it's not, right? Remember, zip codes are not numbers, but it's kind of treating them as numbers because zip code as they're just we are numbers anyway. But it's not a number, so I wouldn't put a lot of stock in this, right? In this one, but because it's treating the zip code as a number, for example. All right, guys, any question on this one? All right, let me just show you another one.
Suji, sorry, this is Kanchan.
Yeah, please go ahead. Yeah.
So the question I would have is like, how would you find the true correlation of a zip code in that case?
Right. So that is a little trick question, and we'll talk about this, right?
Okay.
Yeah, great question. All right, there we go. So one more thing. So because zip code, as we know, is not a number; it's a categorical variable. So what you want to do is like we cannot use simple correlation for zip code. That's kind of the short answer. What we are going to have to do is like use some other metrics, and we will look at some of this in the next lab, the next week lab we are going to do, right? I'll do a little bit more deep dive into that. Okay, so
Got it. Okay.
Yeah. So it's coming up. Maybe not on this, not today in this one, but we will look at this. But another notebook I want to quickly demonstrate is Vaseline. So I sort of like this plot, right? So this is a distribution plot of salary, right? So how do we read this plot, right? So salary on scale, I think it's 5. Is it 5 million? Yeah, 5 million, 10 million, so on and so forth, right? And then we kind of see how many players are paid the salary. And this is pretty telling, isn't it? Like you can sort of see this and you can say, oh, okay, cool. Like most players, like 200 or so players, they kind of make around like, I don't know, like, less than 550 million. 5 million, right? I think, yeah. So, they kind of make like, less than 5 million, majority of the players. Then the graph, dwindles, and, the people who are making really high salaries, that's like a very small portion. And that's true, we know that, right? There's only a few superstars that make a huge amount of salary. Most players, they kind of make, and I sort of like, this one, how, right, kind of dwindle, right, this way. So it's pretty cool. Yeah. So, by the way, can you guys see this, see my screen okay? I want to make sure. Is it coming through okay? Yeah?
Yeah.
Okay, yeah. Because I have a large screen and sometimes, it may look a little too small on your screen. So just maximize your zoom window and you get the full screen, right? So, I even have the browser kind of, right? Kind of, like large, with a large font. Anyway, so I really like this one. So this is cool, right? So it can give you an idea of, salary distribution. Very cool. Okay. Also, oh, this is another cool thing, right? I kind of liked. Remember I asked, is there a correlation between weight and height? So first of all, you have to convert this to height centimeter, right? And then hit a scatter plot to say, okay, how are these things split? And when you look at the plot, it's pretty obvious. Oh, sure, right? When the height goes up, weight also goes up, right? Which is pretty neat, right? And also you can even do do like a little linear regression, right? Kind of right. So do this, and Seaborn will do this for you. LM plot basically meaning linear model plot, right? So you kind of say do a linear regression and kind of see if you can find like a line that goes through that kind of predicts this height and weight, which I thought was pretty cool, right? So I mean we can sort of see it from the bear graph. Yeah, there's a line kind of going through the middle, and you can have Seaborn to do this for you, right? Which is pretty cool. So again, so now we can definitely know, yes, there's a correlation between height and weight. And the reason I ask you to do this visualizing, like, because if you look at just the numbers, right? We just look at the numbers. I don't know about you guys, but it doesn't, I don't see a pattern, right?
Hey, Suji.
Yeah.
Hey,
yeah.
Suji.
Go on. Yes.
Could you go back to that line thing? I didn't quite catch the point of it.
Oh, the line, right? So kind of like this, right? So imagine.
Yeah, I got the scatter plot, but then what were your point about the line? I didn't quite understand that.
So the idea here is like kind of saying, okay, hey, this is the plot. Can you like draw a line in the middle that kind of captures the essence of the data, right? Meaning if I gave you, okay, somebody weighs 200 pounds, can you predict their height, right? So kind of if you look at 200, it's kind of like I'll say they're kind of somewhere maybe in the middle, right? That's the kind of mid portion. And if I say somebody weighs 260 pounds, what would be their weight, height, right? So you sort of draw, kind of go up and say, okay, I'm guessing they're kind of around here, right? You sort of pick the middle point, right, of the distribution. So what this does, this line kind of gives you a kind of like a formula, right? So if I say, okay, somebody weighs 240 pounds, what would be their weight, the height? So I go up, and where you meet the line is where your prediction is, right? This is essentially a linear regression, which we are going to do in a few weeks. Basically, you're trying to, given one variable, you're trying to predict the next variable, right? So almost like a formula. I'm sort of giving a formula saying something like this, right? I'm saying, my formula is, height equal, okay, I'm just making this up, guys, right? Let's see, what can I do, right? Say 1.2 times the weight plus 10. Okay, so again, not the actual formula, but you just get the idea, right? So if you say, okay, somebody weighs 200 pounds, what's the height? You simply plug into the formula. You say, okay, height equal 1.2 times, let's say they're weighing 200 pounds plus 10. So whatever the formula predicts, like, what is it? Anyway, so again, as you can see, math is not my strong suit, but yeah, once you do this math, whatever the number is, right? So basically, that's what the line is predicting. Anyway, it's a linear regression, right? Again, we are kind of getting ahead of ourselves a little bit, but if you just want to know, okay, given a weight, can I calculate the height? Just follow the line, right? That's it. I'm going to stop here. And the thing is, it's pretty cool because Seaborn has a plot. You just simply give the x and y. You simply ask them, hey, can you do a linear regression for me? Can you do like a line? So that's what like it says fit regression true. It kind of tries to guess a line and draw the line for you. Right? Again, optional, but I kind of, I thought this is pretty neat. It's worth kind of showing it to you guys. Again, don't worry about this regression plot. We will come to this when you do our regression in a couple of weeks, right? So just to kind of good guys, very good. So and also, right? So again, this is a kind of a nice correlation matrix and a visualizing using like a little bar plot, right? So again, we know how to read matrix, but when you put it in a nice graph, you can sort of see here, oh, cool, right? Square foot living is about 60, whatever, 80, remember 68% or something, and then followed by bathrooms and bedrooms. Again, you can come up with like little nice, like remember the Kiran's plot was basically right, like a matrix kind of a thing with a color coded matrix, right? So and then but here's another one with a simple plot. So what are we seeing is, right, we are kind of and this is kind of you got to kind of get a sense of what we are trying to achieve here, right? We kind of did like, I look at these, whatever we have done so far, like Legos block, like, Legos, right? Legos block. And kind of what you are doing right now is kind of, you are starting assembling things out of the Legos, right? So sure, right? So here, here's the basic Legos. Kind of we said, okay, how to do mean, median, and all this, right? Now what you're doing is you're kind of assembling the Legos block to take different shapes. That's how you should look at the whole thing, right? Everything should be coming together. So like individual blocks, right? We are kind of, building, making things, little, by putting a lot of things together, we are kind of, doing our analytics, right? So hopefully, it should make sense why we did some basics early on. Just so we had some of the basic skills. So you'd always think about like, okay, what do I know? Okay, I know how to graph this. I know some basic stats. Okay, how can I kind of make sense of the data? Right. So that's how you have to think about this. And another thing I want to give props to Vasilios is like so remember I asked you guys to look at actually that's coming in the next one, right? So I'll show the next lab. All right, guys, does this make sense? So this is stats, right? Again, I'm just showcasing a couple of solutions, which I really liked. They did a really good job. So really good job, guys. And again, kind of learn from this, right? Look at the code sample, right? If you didn't know, okay, Seaborn can do like a little linear regression plot, cool. Now, that's like a little thing you learned today, right? So just, save the code, right? So copy the code into your notebook or something, experiment, and now right? So like I told you guys earlier, I collect code samples. So whenever I see like some cool code sample, I'm like, oh, cool, that's neat, right? I'll make a note of that, right? So, so I can, so let me show you guys if I have this here. Give me 1 second. Any questions, guys, while I'm, right? Yeah, I want to sort of take a quick break and see if you guys have any questions. All right.
Suji, I don't know if you've already done that, but I don't understand the lambda.
Oh yeah, okay, so sure. Let me show you guys real quick. Right, so talking about, so I was going to show you guys some of the code samples, right? So like these are some of the Panda stuff I sort of, like for example, I don't know if I got shown you guys just yesterday, but basically, right? How do you pretty numbers, right? Because Panda usually does scientific notation. So, there's like a little, like a little thing that helps you format the numbers. How do you change the alignment? Remember Pandas was sort of cutting the display into two, right? So if you want to sort of change the display, right? So again, these are little things like, I mean, it probably take me like, 5 minutes of Googling, but once I find an answer, I kind of save them just, you can just write them in a notebook or in a Word document, whatever you guys have, right? Just so, next time, you can just quickly come and say, oh yeah, I know this code is somewhere here, right? So, anyway, so kind of encourage this. In this way, you sort of build up a good library without having to just Google, Google every time, right? Sorry, what was the question? One more time, real quick.
Yeah, actually, it's right on your screen. So I don't understand this lambda function I come across
lambda,
over and over.
Yeah. So lambda is basically kind of the way you look at this thing is basically like, right? So it's a Python construct. So the way you look at this, like, for example, let's say you have an array, right? So, again, this code is not going to work, but you guys get the idea, right? Just say it's an array. And let's say I want to create another array that is basically every element in A squared, right? So one of the cool ways you can do this in Python is you can say take array A, right, and within something like this. For each array A, apply this function. So the function goes like this: lambda. So kind of like, let me just do this and I'll explain the code to you guys. Okay. So lambdas are basically in Python what we call inline functions. If you have familiar Java inline function, you're writing a function, but the function is so small, you don't have to sort of do like the actual how do you write function in Python? Like you say say def function foo, and this is the input x and y, and then and then you sort of do do something here, and then you say return whatever, right, z or something, right? That's your function. So because this function could be as extensive as right, a few lines of code or a few pages of code, whatever. But let's say that you just want a very quick function, you don't want to go through this. So lambda is a nice handy way of doing this. So think of lambda as like an inline function. So how to read the lambda? So the first part tells you what the input is, right? So then after the colon is basically the body of the function. So what's my lambda look like? So I'm saying, okay, I'm getting my lambda, my input is x, whatever the value of x is, but I'm returning x squared, right? That's it. Or, let's say your function, you want to multiply x by number 10. That's it, right? You simply say, okay, every incoming variable, I'm doing the processing and I'm returning 10 times that, right? So what you're doing now is like, so you're saying, okay, go to A, apply this function, right? So what Python will do is it'll basically, for each element, it's going to apply the lambda. Okay, so let's try this, right? So let's say, I'm just making this up, right? So P equal A like this. Okay. So here's the thing, right? So it's going to go through each and then say, okay, for each element, 1. So first lambda, input lambda is 1. X is x, so x becomes 1. What am I returning? I'm returning x times 10, right? So B is now, so the first element of B is being constructed, that is 10. Right? Then second element, now x is number 2, right? So do the math, right? I'm returning 20. You guys get the idea, right? So the lambda is basically a transformation function. Doing it in line. If you have a simple function, you can just do this, right? But if you have like a larger function, then you're saying, yeah, it's not a one-liner function. Then you usually want to write a proper function, and then call the function. And another thing you will notice, like lambda functions don't have names, right? So they cannot be reused. That's why they're called anonymous functions, right? But we write lambdas because just short functions. You just want to we don't want to go through the whole thing. Just want to write a very lightweight function. That's it. Does that make sense on a very high level, right? Yeah.
Yes. Thank you so much. Yeah, this helps.
Yeah. And if you're new to Python, I would definitely recommend doing a little reading on lambda. It's a very nice construct, and it's a good thing to know. So kind of just do some Googling around and kind of read a little bit about lambda functions. Yeah. So,
got it. Thank you.
Good. Yeah. And you'll see lambda is being used, right? And I think you've probably seen this a couple of times, right? So you can sort of see here, right, how they're formatting, right? So things like, they're saying, okay, hey, here's my format function. Okay, each incoming function, right? This is the format, right? So kind of like a little handy functions for you guys to do lambda. Anyway, that's good. All right, guys, let's go to the next lab. By the way, any question on the stats lab, guys? Any questions or comments? So the stats labs, right? Again, bit of a reading, but exercises, I hope made sense and to grasp the concept. Yep. Okay. All right, guys. So that is done. Let's go to the next one, which is basically with data cleansing. All right. So basically, right, we are kind of getting into machine learning. So remember, before machine learning, we have to have clean data. So how do we, use Python utilities to clean up our data, right? That's kind of basically what the idea is. So one of the things you will encounter, a little larger, okay, is how to handle missing data. So example I asked is like, create a data frame that likes list, right? And let's say some of them are missing. Now, so how do we deal with the missing data? Right? So it's not like I'm gonna give you like three sort of, straightforward choices. Either we can drop the data, right? So we can just simply remove these rows, okay? And only keep the rows with the numbers. Or anything missing value, I can substitute 0. Right? That's one option. Right? Now, question for you guys, is 0 substitution a meaningful number here? Like, for example, if I put 0 for the missing values, does it make sense, like data-wise? What do you guys think? Is 0 a valid value here?
I think any real value will misrepresent what's really happening. So a missing value could be probably represent, push a concept of, say here, say a negative value. It makes no sense. So you will understand it immediately when you visualize it.
Right, right. So yeah, so another option is we can, so okay, just to kind of, so 0. So for example, you can argue, okay, you know what? That month we didn't have any rainfalls. That's why there's no record. So maybe, we'll make it as 0. Right? So make it a meaningful number, 0. Right? Or if you want to sort of, you can say -1. But rainfall -1 doesn't make sense, right? You know what I mean? You had negative rainfall. You know what I mean? So again, you have to look at the data and figure out, okay, what makes sense. So in this case, again, there's no right or wrong answer here, guys. I'm just giving you a few options, right? You can say, okay, maybe I would accept rainfall 0 because that's a more, right, that kind of makes sense for this data. Okay. Now, so let's say I could say, you know what, we're going to 0 out all the missing values. Now let's look at the next one. So here I have data, right? People and their height, missing values. Now, can I do 0 substitution here? Is height 0 make sense? Not really, right? Because you can sort of say, yeah, because that's kind of, invalid data. It's like saying, you know what, if you want to keep the data height 0, it's not really valid, right? I can always drop the column, drop the rows, right? I can say, you know what, I'm going to completely lose B and then F, all right? And then just keep the ones with valid data. That's perfectly okay, right? But let's say you want to keep all the data. So here, maybe, if the height is missing, maybe we want to substitute it like an average height, right? So we say average height is like, let's say whatever, right, 160, right? So we calculate the average of this, which is mean. Now we know how to calculate all that, right? We say, you know what, let me calculate the average height of, all the data I have. And whatever data is missing, I'm just going to substitute the average. Because, I'm sort of approximating them to be average height. Because 0 here doesn't make sense, right? So, few options, you got to look at the data and I kind of say, okay, which one makes more sense? Any question on this one, guys? Does it make sense? Kind of, right? How do you handle, missing data? And this is like and that's why I kind of gave you some pointers. There's a lot of reading you can do. You can get pretty deep into stats of how to handle missing data. But for our purpose, I just want you guys to know like some of the very basic rules. Either drop, 0, or find a reasonable like average value, right? So
I would suggest in my own experience that I flag them with specific, say, non-existing, not meaningful values.
Yep.
So when I will do, say, an understanding, an attempt to understand these things, I will have also a number representation of how many of them are actually not making sense.
Yep. Yep.
So the percentage of data collection, how much of the data collection was valid and not valid.
Yeah. Exactly. So what you can do is like, and that's what you can do the next exercise, right? Let me like bring up the next one. Stats. Now that's one. Let me look at the data cleanup real quick. Actually, let me, yeah. I have two notebooks here. Bring up those both. You can see what I'm doing, right? I'm just opening with Google Colab. It's just very easy, right? So, all right. So, right. So when you read these values, there we go, right? See, with the missing values, they will become NANs. All right. Let me also show you guys one more thing here. Come on. Okay, I think I have to close some of these old sessions because otherwise Colab will not let me open those. All right, well, that's loading, right? So, all right, so this is basically just right. So again, same thing. So as you're reading the data, you can sort of see here. Oh, so messed up. 1 second, guys. My Colab is not loading. Let me see what's going on. Give me one moment. Okay. Yeah, okay, sorry. Okay, I'm having some, that's fine. Okay, so we'll give some time for Colab to catch up. But basically what will happen is, right, when you read the numbers without, it'll say NAN, right? So NAN basically meaning not a number. So if you're reading a data and the column is a numbers data, you will see, right? It's being read as not a number. So, but I wish I could show you guys because my Colab is kind of freezing up. So yeah, right. So we have seen a couple of options. So what this notebook is working through is like, you're reading a notebook here, right? And I'm asking you like, say, okay, do some to-do items, clean up some data. So let me actually see if I can open this notebook here. Okay, there we go. Okay, you're reading admission data. So again, I'm saying, okay, use describe function to see what the data looks like. Okay, and also you can describe based on certain columns. You can say, I only describe GRE column and say GPA column. So you can just give the column numbers as you want. It's working now. Oh. All right. Let me try one more time here. See if Colab is back in action. If not, we'll just use that. Okay. Okay. Then I'm saying, okay, first thing is you can just drop all the null values. And what do you get, right? So that'll mean like, any row that has any null value will be dropped, right? So that's an option. You can sort of say, okay, you know what, I'm not going to deal with null values. I'm just going to drop all the data that, yeah, all right. So it's not happening here. Sorry. All right, that's an option. Or next option, you can say, okay, I'm going to fill in the missing values. So right, so there's a fill in a option. You can give like a default value. So you can give it 0, for example. Oh, I'm telling you guys, okay, you know what? You can do like a per column default value, and that's what I guess Vaseline was talking about. You can say, I don't want to just do blind zeros. Like for example, if I see a null value in the admit column, I want to substitute -1. So I know it's not a valid value, right? And if you see a null value in GRE column, I'm going to say -100. Right, so you just here you simply say minus. Look at the hints. You simply say -100, right? So on and so forth, right? So you can even specify per column default values. Will actually fill the fill per column. Pretty straightforward. Or you can replace the value. For example, let's say let's say you're expecting data in say centimeters, right? And then, but you got the data in say, like remember early on like feet and inches. So you can do like a little replace. You can do like a little formula here. You can say, okay, anytime you see this value, right, replace this value, right? So you can very easily do that, right? So replace function. Again, I wish I could show you the code, but no, my Colab is kind of stuck, right? So, okay. Oh, actually, okay. I guess I need to log in again. All right, guys. Okay, let me just not deal with it right now. Let me just show you the code right now. I don't want to waste too much time here, right? And also, you probably see in the rank column, you'll sort of seen, right? There's an X here. I don't know if you've seen this. Come on. All right. Finally. All right. Let me see if this works. Excellent. All right. So just keeps waiting on this one. I don't know why that is. Let me see if this works. Anyway, so it looks like my Colab is kind of having some issues. So anyway, so let's see if this works. If not, we'll kind of move along. All right, guys. So sorry about that. Okay, right. And then also, for example, if a column has, let's say you want to say, this column only can have these values. So, and here's how you can sort of filter out, right? And there are a lot of other ways of doing this. Here's, again, some code example you can sort of, replace, because here the data is pretty simple. It's only like 20 rows or something. You can visually inspect it. But imagine you have a million rows. You cannot inspect it visually, right? So you need to have some strict guidelines to say, okay, hey, I want to make sure there are no null values or inane values, right? And I want to make sure this column only has these values, things like that. Yeah. So, all right, guys, does that make sense? Again, please take a look at the solution files, and you will see, these two are pretty good. And one thing I wanted to, right, if you look at the zip code column in the housing data, you may have seen some of the zip codes are tagged as -1. I don't know if you guys have seen this, right? In some entries, zip code is -1. That means they didn't have the zip code entry. So one of the ways you can kind of do this, like you can say, what, yeah, I need zip code to be a positive number, right? And you can say yes. This way, I know this is the invalid zip code. Right? And I like what Vaseline did here was like, so basically said, even if I have a positive number, is it a valid zip code, right? So you kind of, go away, right? Basically, sort of, you actually load zip code data, right? And do like a cross check. So you actually download the US zip code data, right? You can look at the code here, right? And then basically cross-reference and say, hey, if I have a zip code says 123, is that a valid zip code, right? Anyway, right? So you can sort of take a look at this one. So again, I think that was pretty cool. Being able to validate the zip code. Again, I wish I could have shown you the graphs. My Colab is kind of completely, gone. But anyway, yeah. Please look at the notebook. You know what? I'm going to just something's going on. I'm just going to X this out. Not sure what's going on with Colab right now. But yeah, so please look at those notebooks, guys. Those are pretty good. That's why I want to highlight them. All right. So again, right, you can do as much, go a little extra to kind of validate your data. So you can even do simple validation, like say, okay, I want to make sure zip code is not negative, right? That's fine. But maybe you can sort of, I would say, I wanted to do real cross check and make sure I actually have the actual valid zip code. So, good, guys. Any question on this one, guys? Right. So where are we on the overall scheme of things? Basic stats. Right now, we just sort of know how to kind of slice and dice some data and get a sense of the data, right? And you can see in some of the graphs people have come up with, like you can do distribution graph, box plot, right? Those are some of the nice way to kind of visualize the data very quickly. Cleaning up data. So we looked at some of the basic cleanup things. You can drop the rows or replace them with some value. What the value is, that depends, right? And so look at the solution files. Okay. I'll give you some idea. Good guys. Any other question on this one? Two sections, stats and cleansing.
I don't know if you have it in plan, Shruti. I don't. Can you hear me?
Sure. Go ahead, Vaseline. Yeah.
The data cleansing is one stage. From my experience, data enrichment is also next stage. And I don't know if you have a plan to talk about data enrichment. It's something like, for example, look, imagine you have sales records. Yes. Nobody's going to tell you if it was a weekend, or if it was a bank holiday, or if it was special. All these pieces of information are publicly available, but not included in your data set.
In your data, exactly.
This is what I call data enrichment.
Yep.
After the data cleansing, you can do the data enrichment.
And we will look at, actually, yeah, that's a great point. I have some of this coming up. There's a nice graph I want to show you guys, and it's kind of too bad I couldn't see this. Yeah, let me see if I can get one more try. Okay, so now collab is back. That's good. Oh, so again, so now I can sort of see some of the data, guys. So when you guys do describe, right? And this is what I want to show describe here, guys. So when you do describe will tell you, for example, right? So for example, this data frame has 20, right? 20 rows altogether, right? Sorry, 100 columns, right? But when you describe, it's going to tell you, right, which of them are null. You know how it says count, right? So out of 20, this one, the admin column only has 18 valid data. So there are 2 null values. GRE column only has 19, right? So there's out of, since I have 20 rows, 1 null value, right? So you can quickly sort of see how many null values are there, right? And also it gives you the normal, minimum, max, standard, all the stuff, right? So that's pretty good. Okay. And also if the rank column, it says it says not a number because there's an X in the rank column, if you can see this, right? So what Pandas does is it's sort of treating the rank column as a string, not a number, right? So if it's a string column, it doesn't make sense to do like, mean and minimum, right? Because they don't make any sense. So that's why you see NaNs here. But for number columns, it will calculate the basic stats, right? So now you can say standard deviation, you guys know what it means. What is 50%? This is the median, right? So now we know how to interpret all this. Okay. All right. So this is good. So there's a graph I'm looking for. This one, the next one. Yeah, so let me actually fix this real quick. I know you're reading the local data, so one of the things, again, as I'm doing this, you can sort of see here, right? Here, you can try the, read the local. You can download the data locally and read it, or you can simply give the URL and read it, right? So this way, Pandas, from as far as Pandas perspective, it's the same. So it's pretty cool. All right, there we go. This is what I want to show you guys. I like this graph, right? So what do you guys see here? So this is basically what he has done is like, he looks at the sales, date, right? Converted into actual date object, and then so we started extracting, year and month. Okay. So now you're doing a plot of, houses sold per year. That looks like a pretty strange graph to me, right? Can somebody explain this to me? Why is this behavior like this? It seems like, sales are still declining.
Financial crunch.
Oh, sorry, one more time, Vasilios. I think you're on the right note. Tell me one more time.
It is a financial crunch. Not many people have enough money to buy houses anymore.
Right, right. I don't know if you guys remember. And Wesley, this goes to the point of data enrichment, right? So let's say I'm looking at this graph. And I say, what's going on? Why is this? I mean, typically I would expect the sales to be kind of more or less the same, right? Per year after year. But I see tons of houses sold in 6 and then steady decline. Remember there was a recession, 2008? Anyone remember this? There was a housing crash. There was a housing bubble. So 2006 was the peak of the housing bubble, right? And then so housing market crashed and 8 and right. So then it took forever to kind of recover, right? So you can see the recession kind of like if you ever plot like data before, it'll kind of you see like it'll kind of go up and up and up. 2006 is the peak, and then crashes, right? Sales kind of decline quite a bit. Now, there's nothing in this data that says there's a recession, right? And this goes to your point of what Vasilius you are making is like there are sometimes you have to bring other data to enrich the data. Let's say I don't know anything about let's say I'm just looking at the data. I don't know anything about the recession happened 2006, 2008. Then this graph will make any sense. But let's say I'm looking at let's say stock market data or some sort of a recession data, and then I say, now I see what's going on, right? I can quickly kind of look at them together and say, yes, there's a housing bubble and there's a housing bust, right? And kind of comes down. Pretty cool, right? So that's why again I'm a big fan of graphing data, guys, because when if you look at the numbers, it's very hard to find patterns. But when you do like a simple graph, just say, hey, I want to just plot houses sold for each year. Immediately you see a pattern, right? Remember this because we are going to do this analysis. When you do regressions, we are going to predict house prices, and the knowledge you guys find here will come in handy on figuring out why the recession is behaving the way it is. Because you can see the data is very lopsided, right? Because we have a lot of data for 2006 and 2007 maybe, right? And then the rest kind of very minimal data. And you will see our model can predict prices very well in 2006, 2007. Because why? Because it's learning a lot of data. But if you try to ask the model to predict on, say, some household in like 2015, it will not do as well because it doesn't have a lot of data to learn from, right? So, cool. And also I'm asking what's the data clean. So basically, kind of saying, hey, you can look at the zip code, right? And I think that's pretty much the only thing that needs to be cleaned up. You say, okay, how many sales have valid zip code, and go from there. All right, so it looks like we are 83% of the data is clean. Okay, is that good? So that's why, right? Even when you're doing data cleansing, you kind of want to do like some basic visualizing just to understand the data. All right, let me bring up the next one real quick. Let me show you guys one more thing there. Hopefully Colab is working. Okay, good. So this is the info column, right? So when you do info, it'll tell you, right? For example, it's going to tell you, okay, how many records do you have, right? There's no null values, just invalid values, right? And also what type of values you're getting, right? So as you can see, zip code is treating as an integer. As a matter of fact, it's not, right? We know it's not, but it's all numbers, right? So in reality, we kind of probably want to make it a string or something, right? So you can specify the type if you want, but for the most part, we can just leave pandas to figure it out, and it's fine. And here's the right. You can sort of see here. Okay, if zip code is negative, we are like 4,000 entries, where the zip code is less than, I think it's -1, right? So there you go, right? So here's like a nice little thing, right? You can sort of see here, right? All my data 27,000 or so, right? But positive zip code and missing zip code. These are -1s, right? And here's kind of the nice thing, it's basically saying, yeah. I think this house is for sold. I think, yeah, there we go, right? Nice plot again, right? You see the trend very clearly. And here's kind of the zip code validation, right? So you actually download the actual zip code data and sort of cross-referenced. Again, so the code is not it's not run for me because I don't have the data here, but you just get the idea, right? And you see like a little plot at the end. Right? So anyway, pretty cool stuff, right? So we're cleaning data, and also we are also kind of understanding data. All right. Any other questions, guys, on this one? All right, so I sent you guys a few slides. Basically, the way you sign up for that is right here. Okay. So from your welcome page, the section. So I will periodically send out some class material. So if you just sign up here, you'll get those slides. Okay. So far I think I sent you guys 6 slides. Right. I'm gonna look at something real quick. It's called feature engineering. So this is what sort of you're going to be. So we're kind of now sort of getting into machine learning territory. Now we understand the data sizes, right? So feature engineering kind of encompasses a lot of things, right? It can be data cleanup, data augmentation, or data enrichment, right? So all of this kind of we kind of call them kind of feature engineering, right? And this is very, very important in machine learning. Right? So let's start with an example because I've already seen. Remember the house sales data, right? You have bedrooms, bathrooms, right? So these are my input data. So, right, for my algorithm, I'm going to input bedrooms, bathrooms, and square feet. And sale price is what we are trying to predict. And that's my output. So inputs are these 3 guys. My output is this. Yeah. So there's one thing called feature selection. And this is something, we will, I'll just give you like a quick intro today, but as we do our machine learning labs, we will kind of continue to revisit this. Let's say somebody gave you a data, data that has 100 columns. Do you really want to put all 100 columns to the machine learning algorithms? Probably not, because sometimes not all the columns matter. And sometimes if the more columns you add, they may create more noise than signal, right? So they can drown out the signal, right? So we want to be kind of careful which columns we actually include in our machine learning model. And this is called feature selection, meaning which features do we select, right? So let me talk about this real quick. So imagine I'm a bank, customers are applying for a new credit card, right, or new loan, for example, right? And I have all this data about this customer. Now, if you are considering this, which of the attributes you guys will actually consider to make a loan decision, if you should make this loan to this person or not? What do you guys think? Feel free to speak up or type in the chat window. And also, you have to tell me why you would choose that column. So what do you guys think? Which of these we are going to use to make a loan decision?
Have direct deposit, of course. That's
okay.
Major.
So direct deposit. Why is direct deposit important? Why do you think that's an important column?
If you're talking about Europe, for example, now it has become a mandatory part of having, say, a mortgage or a loan, especially for mortgages. Before, you could have up to 120% of the value of the house as a loan only, without. So that's why you had also a housing bubble in Europe. Yes.
Right. So Vasily, a quick question: where are you located? I'm curious.
In England, near London.
Gotcha. Okay. Very good. Yeah. Yes. Good to have a different. I mean, even though this data is more US centric, but I mean, yeah, I appreciate the input. Yeah. So having direct deposit basically is a good one to say. That means you have a relationship with the bank, right? Meaning, so that your paycheck comes to you as a direct deposit, so bank has some idea of how much money you make. Yeah. So that's good.
Yes. And then you say the income is the second major, I could say, factor.
Yep. Yeah. So you guys said, okay, income is a pretty good, right? You want to make sure this person has sufficient income to pay off the loan. Yeah. Very good. Income is important. Very good. Yep. Let me look at the chat window here, guys.
Third, I could say, is going to be if there is an ownership of a house, so there is going to be a secured loan or not.
Yeah. Yeah. Exactly.
And so fourth, I could say, is the age based on how many years of employment are left.
Gotcha. So let me look at this owns a home real quick. Okay, I know some of you, even the chat window, you guys mentioned owning a home is important. Why is it important? Can somebody else kind of tell me why owning a home is important factor to consider? What do you guys think?
That's a mortgage commitment.
That's right. Yeah, basically like, that's basically, like, okay, it's kind of like, okay, how this is your income, for example. Out of the income, like if you already have a home, then you have a, you probably have to pay the mortgage on that one too, right? So and then how much money is going to be left over, right? So owning home is pretty good indicator. That's very good, guys. Let me see. And again, so I'm going to ask kind of different people to chime in just to make sure. All right. Yeah. So I see a real good comment from Balaji. It's like age.
So,
what do you guys think?
Before that, just a disclaimer. I get too technical because I'm also a realtor. So
good. So I welcome the extra knowledge. So yeah, I saw your comment about age is discrimination. That's a good point. Would you explain that to all of us?
Yeah. So basically, in the U.S., decision to either sell a house or buy from, and also decision to extend a loan, things like that. They're not supposed to ask for the age, race, all the several different things, because there's a law that's passed in the government that says it's discriminatory to decide based on which race you are from or how old you are, things and so forth.
Yep, exactly. Very good point. Thank you so much, Balaji. Yeah. So, but if you think about this, I mean, age might be a good indicator because if the person is too young, right? Maybe they don't have enough income or enough experience to support a loan. If they're too old, maybe if you're like 70 years old, right, or 80 years old, you probably don't want to take out a 30-year-old mortgage anymore. You know what I mean? So, age, you might think age is something we should consider, but legally we cannot, right? So, and that's a part of the exercise, guys, because even though I have a lot of columns, to consider, doesn't mean I can use all of them. Yeah. So that's why we are doing the exercise. Is that going to make sense? Yeah. So age, yes, even though we think it might be a good indicator, we cannot use it legally. All right. Okay. Very good.
Question on that. When was the age became somehow an illegal piece of data for consideration in the United States? Because I think probably in some European states, they may still use it and utilize it in their.
Yeah. I think it's fairly recently, I believe. Again, Balaji, you can maybe give me a better answer.
No, it's been. I mean, I need to go back and flip my pages to say the exact year, but it's been out there for several years now.
Yeah, because no
age over 20 plus years.
No age discrimination, right? Because right? Right? Exactly. Yeah.
Where they can ask for an age legally, they can ask for an age is, let's say you have a 401k account and you want to start dispersing the money on it.
Yeah.
You have to be at least 58 years old. Or 62 years old. So at that time, they can legally ask you, how old are you? But exactly. For employment or anything in the US, you cannot ask for age. How old are you?
Yeah. Very good. All right, guys. So good. Okay, let me sort of move this along kind of quickly because I don't want to go too over long. Oh, and Raju said they will ask for date of birth. Yeah, so that's true, but that is more to verify your identity. Right. For example, if they want to, verify your credit or something, right? You need to have your date of birth, but they cannot consider this. I mean, they should not, right? Legally, to make a decision about your loan.
Even marital status is not.
Oh yes. so I can put this up here. What do you guys think? Okay, so let's kind of forget the legalese for a moment. Like, let's say there's no legal implication. Would you consider this? Would you consider if the person is married or not when you're making a loan? What do you guys think?
It is not.
Yeah, right. So you can sort of say, okay, maybe not, but probably be,
I cannot choose to give a loan or not give a loan because
it was married or not, right? Exactly. Yeah. So anyway, so right. So some fun data, right? Even though it looks pretty simple, once you start digging into it, right, you will see it's not as straightforward, right? You have to consider a lot of other factors. All right, guys. One more thing. Let's see. Okay, let me do the chat window here. Very good. Yeah. So, nice comment from Shava. Thank you. Would you guys consider zip code as a part of making a loan? Right? What do you guys think? Zip code is like where you live, basically, right? Kind of, would that be a factor?
So it depends on what type of loan you're making. Like if it's a collateral loan, and if there is a property tied to this, then they would look into the zip code and see, how much the assessment value for the property. So
exactly.
Yes.
Right. For example, like zip codes, typically, at least in the US, right? Zip codes are very big indicators of your house value, right? There are some, good zip codes and, poor neighborhoods, right? So a bank might look at your zip, let's say you're applying for a mortgage loan, they might say which zip code your house at. Let's say you're applying for, let's say, car insurance, right? They may ask you, which zip code you park your car, right? Because, if the zip code has a lot of vandalism, your insurance might go up, right? So anyway, right? So there are a lot of factors we can consider. So some of them, and you guys did pretty good, right? So for example, from this, let's say I sort of extracted like age, income, and mental status, right? Again, age is kind of questionable, right? It could be legal, it may not be legal. So this is basically called feature selection or feature extraction. So again, the takeaway here is, right? Some of them features are important. Some of them you cannot do legally, right? So we have to zip through some real quick, for example, right? And this is what we just mentioned. For example, race, age, right? Even sometimes the address may not be used when making a loan, right? Legally. So you have to consider that too, right? Which one you can use legally. So, all right. Again, I'm going to zip through some of these things real quickly, guys. All right. Now, what we're going to look at is when you look at features, when a feature is made as in like input, right? Some of the features are numbers. Some of the features are not numbers. Like for example, how many bedrooms in the house, right? That's a number, right? You guys have seen the housing data. There's a column called house type. There's a single family townhome apartment, right? It's not a number. This is what we call categorical variable, right? Meaning a string variables, right? Even things like, what kind of item do you have, right? So there are not all the data is going to be numbers, even though we would like the numbers because numbers are easy to graph and visualize and everything. Not everything becomes numbers, right? So when you have categorical variables, things like, right? For example, like, let's say single married, right? How do you convert these to numbers? Because machine learning algorithms deal in numbers, so we need to convert these guys to numbers. Now, let me just very quickly, and then so one way you can do is simply, right? You can assign a unique number for these, different things. For example, you can say married equals 0, single equal 1, divorce 2, right? And then so this is the original data. You sort of convert them into numbers, right? Becomes like this, right? All the married is mapped to 0, all the singles mapped to 1. Makes sense, right? So we convert them to numbers. So you think, okay, this is fine. We are good to go. But there's a little thing here. Because since these are numbers, some of the algorithm will try to interpret them as regular numbers. Even though we know it's not a regular number, it's just like just a placeholder. Some of the algorithm may start thinking them as like, start assigning order to the numbers. So they may say 2 greater than 1 greater than 0, meaning, 2 divorce greater than single greater than married. Right? So that's not the right meaning we want to derive from this, right? Because these are not real numbers. So, but some algorithm will get confused by just having numbers. Remember the zip code example? It's a perfect example. Remember the zip code example earlier? Even though zip code is not a number, Pandas is thinking it's a number, right? So to make sure this doesn't lead to this confusion, what we do is we turn this what we call one-hot encoding. It's a very simple concept. So here's what one-hot encoding is, right? So here you can see I have 3 distinct possibilities: married, single, and divorced. So what we do is we create 3 dummy columns: is married, is single, is divorced, right? And you can sort of see, how this is mapping, right? So married, when the thing is married, only married is true, everything else is false. Single, right? Only single column is true, everything else is false. So what I've done basically is I sort of converted this column, right, single column, into 3 columns, basically. That's basically called 3 vector columns. Why 3? Because I have 3 unique values, right? Divorced, married, and single. That's why 3 unique columns. If I had 10 unique values, I would have had 10 different columns, right? And then converting them. So what I'm doing essentially is I'm converting this, the string data into what we call a vector data. So when the machine learning algorithm looks at this, it immediately knows, okay, yeah, this is a vector. And the reason it's called one hot, right, is basically, if you look at the entire vector, only one of the vector is true, a hot, right? Everything else is 0. So now if somebody gives the data like this, there's no confusion, right? There's no way of interpreting the data as like, actual numbers. We know it's a vector. Does that make sense, guys? Right? So how to convert the data from like a string data into, right, into a vector data. So these are all basically what we call feature engineering. We are kind of converting the data from original format into a format using machine learning. And this is what we will do next. I kind of want to give you like a quick heads up. I'll give you some reading material on this one, but I want to make sure you guys understand why we are doing this. Yeah.
But may I ask, this has
Sure.
got something like a limitation on, say, the individual, say, unique values you can find.
Mm-hmm.
For example, if we try to apply this to a zip code column, are going to get confused, I would say, and overload the system for no reason.
Yeah. So so that's a great point. So think about this, right? Because here I had 3 columns, right? So I had 3 dummy variables. Oh, sorry, 3 dummy columns, right? So it was pretty straightforward. But think about it for zip code. I want a lot of unique values, right? And what is one-hot encoding saying? For each unique value, you have to create a column, right? So you might think that's very expensive, right? Let's say just for argument's sake, I have 1,000 unique zip codes. So I'm going to have 1,000 columns. And you may think that's a waste of resources, right? Because I'm creating 3 dummy columns. I'm sorry, 1,000 dummy columns. But don't worry, because the way pandas will store them, right? Because imagine if you have 1,000 columns. What really matters? That out of 1,000 columns, only 1 column is true. Everything else is 0. So I don't have to store like actual 1,000 column data, right? In the memory. I'll just do 10 for just as right. Let's say 0, like arrays 0, 1, 2, 3, 9, right? So let's say only this guy has a value, and you could actually store everything else as 0, 0, 0, right? That's fine. But honestly, only thing that matters here, right? So what if I just just store this guy? Let's say this is column number 4, right? So I simply say, okay, I have 10 columns, but only only index 4 has a value. So I can store the arrays very effectively. The one-hot encoded arrays, I don't have to store the whole 1,000, right? 1,000 thing in memory. I can simply just store what matters. Does that make sense, guys? So don't worry about one-hot encoding, even though it may, when we draw this, we cannot draw them as like individual columns, just to illustrate the purpose. But when they're stored in the computer memory, they are stored in a very compact notation. Because the nature of this is I only have to remember which one is 1, right? The others I know for 0, right? Does it make sense, guys? Yeah. So you can encode, one-hot encode, even column with like lots and lots of, distinct values. That's fine. Memory, you're not going to blow up the memory.
Hey, Suji.
Yeah.
Yeah. Yes. So this one-hot encoding would come after you have done your exploratory data analysis. Probably drop some columns and stuff like that, right?
Yeah, exactly. So it's kind of, if you look at the sequence, you guys are sort of doing the first part, right? Loading the data, cleaning up the data, right? Kind of analyzing it, like doing some basic analysis. So you understand, okay, hey, this column is like, string column, right? This column is number column. So you cannot know this already. These are sort of second step. Yeah, good way, right? Sort of thing like little, stage by stage. So what we have done so far, stage 1. Loading up the data, cleaning up the data, understanding the data, right? This is stage 2. Now we are going to select which data we are going to feed to the machine learning algorithm, right? Yeah. Mm-hmm. Does that make sense? All right, guys. So I'll sort of stop here. So we are going to do a few exercises on this one, and I'll just do one more, right? And then we'll stop here and we'll do this, pick up next week. Now, this is going to the point of remember you're saying enriching data. So imagine I showed you house sales data like this, and let's say this is like a median house price, and I ask you guys, okay, which city is most expensive? And if you just look at the raw data, you might say, okay, Mountain View is the most expensive city, right? Because that's sort of the has the highest price. But that's not a good decision, because even though I see the median house price, I have no idea how big the houses are. So for that, let's say I went and got I also got a median house size. Then I'm calculating price for square footage. And this is a very common metric here used here, right? Because if we just say, tell me the house price, I'm like, okay, so okay, fine, that's 1.2 million, but okay, how big is the house? Is it like a 1-bedroom house or like a 10-bedroom house, right? So for that, what we do, one of the metric we use, like we take the size of the house and we sort of calculate how much per dollars per square footage. And now I can do a easy comparison. I can say, okay, now this square footage gives me the size of the house, do the pricing, then I can say, okay, now San Francisco is the most expensive market, right? Because now I can sort of compare the numbers on a normalized, in a normalized way. Does that make sense, guys? So even though sometimes you're just given some data, you may have to go get other data and create other columns. So this is called, creating new dimension, right? Because for example, this price per square footage, I did not have that in the original data, right? I had to kind of create it, and maybe this is the column I will use for my machine learning algorithm, right? I may not use the the raw house price, right? I may use like a normalized column like price per square footage, right? Again, why are we doing this? So we can do like an apples to apples comparison. Yeah. All right, guys, that's it. So that's kind of theory, and these slides are sent out to you guys, and I'm working on some of the same pointers and exercises on this feature engineering. I'll send this out. This coming week is light, so we'll kind of I want to use to catch up. It'll also give me a chance to catch up as well, and then we'll start doing feature engineering the next week. Does that make sense, guys? So if you have some things you need to catch up on, use this week. Good, guys. Any other questions before we end the session? So the recordings are going to come to you guys. If you look at our course guide, go all the way to the bottom, right? So under the session summary, you'll sort of see, right, what's basically that's where you see the recording, what we discussed in the session, and also assignments, and also answers to the assignment, right? So everything will be basically here, right? So everything in the welcome page. Yep. Good, guys. Okay, so that's it for today. We are done with the official session, but I'm happy to kind of hang around a while, a little more if you have any questions. But we are officially done. Keep an eye on in your emails, and then I'll send out. But again, next week is a light week, right? We don't have any big ticket items, and we'll pick it up after that. Good, guys. Thank you. Anything else?
No, thank you. Thank you for the hints.
Very good, guys. Again, thank you so much for being part of the class. So we'll take a break, and then next we'll start the next milestone the week after, right? Okay. Thank you, guys.
Thanks. Have a nice day. Bye-bye.
Bye.
Thanks, Sid.